Hi everyone, this is Sirius back here again with another video. Today we'll be looking at a question from the 2015 paper. Right, it's from paper 1, question 15. Alright, so let's take a look at this question now. The formula of an oxide of an element Y is Y2O3. 8 grams of Y2O3 contains 5.6 grams of Y. How many moles of Y does 5.6 grams of the element contain? Right, so how do we go about doing this question? We see that you have 8 grams of Y2O3, right? And it mentioned that there is 5.6 grams of Y in this 8 gram, right? So that leaves 2.4 grams of O, right? So since we have no MR, we are unable to find the moles of Y. So what do we have to do then? We have to go ahead and find the moles of O, right? So how do we go about doing that? We know that moles is equals to mass over MR, and by taking 2.4 grams divided by 16, we will be able to find what is the mass of the moles of the O. But in this question, that will not be needed in terms of the exact answer, because you can see that they leave their options all in like 2.4 over 16 times another fraction, right? So this tells us that we don't really need to find the exact number of the moles of oxygen in this question in particular. So we can just leave our question as that for now, as in for the moles of oxygen, and we can go ahead to find the ratio. All right, the ratio of Y is to O, right? We know that the ratio of Y is to O is 2:3, right? So how then can we find the moles of Y? Therefore, moles of Y equals to 2.4 over 16, right? Divide by 3, okay? Divide by 3 times 2, right? So if I were to put this into fraction, it will be like that, right? And we know that we cannot divide fraction by another fraction. So what can we do then? We can actually make it like that. 1.6 times 1 over 3 times 2 over 1. So what do we get in the end? We can combine these two and we can get this expression right here. And so which option matches this expression right here? We can see that it is option A, and that will be your answer for this question.